For my Patreon only subscribers, here's a different cut of the AGS TRIO receiver service, and I'm going to put a lot of the stuff in that was removed from the original one because there was a lot of tuning. It looked like I got this in like 5 minutes, but I actually spent hours getting this thing working properly. I'll show you the procedure I had to go through because I had no schematic to work with. Well, today I have a real old beauty here. This is an old AGS TRIO. AGS stood for American General Supply. This was built by the TRIO company. Anybody who knows the history of TRIO, TRIO later became Kenwood. So then it was TRIO Kenwood. And of course, today Kenwood is JVC Kenwood. But anyway, a little history. This is an old AM/FM receiver that I received to have a quick look at this. As we notice, the base control is broken. And that's how I received it. The client that owns it, the control was bent, and he tried to straighten it and ended up with a broken control. So we're going to try and find a new control for this thing. I'm going to pop it apart. We'll see what the value of this control is. It's probably a 50K dual pot. That's what I'm thinking that this thing's going to be. But I figured you guys might like to get a look inside one of these old beasts and see what they look like. Pretty dusty. Lots of old caps in this thing. Wow. Let's dust this off first. We'll get the air compressor out here. So it looks like it's a 30. Is that 309 or 30G? Anyway, it's all solid state, as you can see. It's got your AM/FM dial, tuning meter, speakers on and off, power on and off, volume control split. It's got a AM, mono, FM, automatic stereo, and phono. We're going to connect this thing and see how it sounds. And anybody dare to guess the power output on this thing? Anyone want to gander what the power is? Not very much, is what I'm going to guess. Output transistor should be underneath here. Whoops. Cut. So the output transistor should be under this shield. Let's take a look and see. Suspense is killing you, isn't it? SD 143. Now, according to my NTE cross-reference, that would cross-reference to an NTE 175. The data sheet for an NTE 175, which is going to be a replacement, so it's going to have probably higher specifications than this. But it's rated 300 volts and 350 volts. No, the 175 is 300 volts. And that's your collector to emitter, collector to base, 400 volts, emitter to base, 6 volts. And it has a 2 amp continuous, 5 amp peak. Collector current and base current is 1 amp. It says power dissipation on this device would be 35 watts. But you're not going to get 35 watts out of a receiver like this. This is not a Class B amplifier. This is they call it a complementary output, but basically it's using 2 NPN transistors, and it's using capacitor coupling for the speakers. So conservatively, it's probably rated at 20 watts per channel, I would guess. A little history in amplifier design. This is a complementary output. It's called a quasi-complementary output, and it uses 4 NPN transistors, 2 per channel. The reason for this is, in the development of power transistors, NPN transistors were the first transistors to be developed in the power type transistors. You've got 2 different types of bipolar transistors, NPN and PNP. And in the early days of the power transistors, the PNP transistors were available in many types, but they were all low voltage signal type transistors that were used in circuits like the driver circuits and so forth. But when it came to the power transistors, PNP was behind the NPN in its development phase, and even when PNP power transistors did become available, they were much more expensive than their NPN counterparts. So most amplifier designers of the day went with this quasi-complementary output, which used 2 NPN transistors operating together, and they use a capacitor to remove the DC component that would be present at the midway point feeding the speakers. This was a way of achieving the higher power with a single-ended type output from 2 NPN transistors. Once the price dropped of the PNP output, then they moved to produce Class B amplifiers, which used an NPN transistor and a PNP transistor, one to produce the positive portion of the waveform and the other produced the negative, and they would hand off at the switching point. And that created its own can of worms called switching distortion, which was soon overcome by the Class AB design. The Class AB design, what they did was they introduced a small amount of bias to the base of the output transistors to keep the transistor that wasn't conducting from going into full cutoff. So basically how it works is you keep a small amount of current trickling through your emitter to collector junction at all times, whether there's any signal passing through it or not. And then as the waveform increases to the positive swing, the transistor that's amplifying the positive will go into more conduction, while the transistor that's amplifying the negative will stay at its idle. As the waveform reverses phase and it crosses the zero baseline and goes into negative, the positive transistor is now at its idle current and the negative transistor is going into its conductive phase. That's a Class AB design, and that was commonly called a push-pull. That was used in vacuum tubes as well. Anyway, we can tell by the size of this transformer that this thing's not going to have a whole heck of a lot of power. I'm going to guess 20 watts per channel, but it could be less than that. It might be 15, but I doubt that it's going to be more than 20 watts. But I figure we'll hook the speakers up on this thing, and we're going to take a listen to it. Now, before I do, I want to make darn sure that my speakers are both referenced to ground and we don't have floating negatives, because my test bench speakers are grounded. The two negative terminals are grounded together. So I'm just going to get my meter and measure the negative terminals just to make sure that they are in fact connected, and then I can hook it up to my bench speakers. Otherwise I have to find some separate speakers. So negative terminal, negative terminal. Yes, okay, good. You see, we're grounded here, and we're grounded to the chassis as well. So the negative terminal is indeed grounded, which is what I fully expected. So let me connect this up to my bench speakers, and we'll take a listen to this thing, see how it sounds, and then we'll get the bottom off it and take a look at the control that's broken, and then I'll have to try and find a replacement control. Let me get the speakers hooked up. Okay, the moment of truth. Volume, minimum, power. Speakers are speakers are on. That's interesting. When the button's pressed in, speakers are off. That speaker's on. Let's just see. It's on AM, so let's see. Oh, controls are dirty.
Visit MeridianMeats.ca. Hi, I'm Josh Penner of Meridian Meats and Meridian Farm Market. Fire up the
We have lots of noise. We have lots of noise that blocks out most AM signals around here.
3 for just $9.
Lots of digital noise from digital devices running here at my place.
Sulaki. Head to Domino's right now because this deal ends.
Let's take a listen to FM. Put it in stereo. Appears to work. No antenna on it either, so I'm taking it down to my modulator here. I think that's my modulator.
Over the cap all day long, and it's, you know, I've asked people.
Yeah, that'll be it. Looks like the stereo light might be burnt out. Is that this thing or not? Tape source switch is kind of, that needs to clean. That switch needs to be cleaned. Needs a new light bulb for the stereo indicator. Let's get the bottom off it and get the controls cleaned. See if that improves the operation, and then we'll deal with this bass control. So here's the broken control on here on the bass control. You can see all the capacitors strapped around it. It's a 50K dual control. This is the treble control. I'm just going to give them a shot of cleaner first, and we'll see how they clean up. So first we'll get the volume controls over here. That control's sounding good now. Function switch. I'll do all the rest of the switches while I'm at it. That tape monitor switch doesn't appear to be in great shape. Just gonna put an antenna on the FM input.
Come on up.
That'll work a little better with an antenna. For the heck of it, I'm just gonna put some JB weld on here. I'm just gonna try and just see if I can get this control to stick back together. See if it works. That's in case in the event that I can't get a replacement control, I might be able to get this knob back on here, and as long as it's not really pried upon, it should stay in good shape. So we're gonna hold this thing here steady and let this JB weld set up for a while. Well, now this is JB weld just setting up. I'm going to let it sit for a while before I try and reattach the knob. Let's just see how well this thing performs with an antenna on it.
That went through. Sounds like it's pretty rough.
Visit VWOffers.ca. C'est ton coin pour t'en aller.
John Lee Hooker, died at the age of 83, just before his birthday.
I would say for an old receiver, this thing's actually doing pretty good. It needs to be in good shape on this thing. Needs a light bulb. Easy enough to change. What voltage this thing is here. Let's see if I can find out the voltage. Probably a 12 volt bulb, I'm guessing. 8 volts. Oh, maybe not blown. It doesn't look like the filament is burned out on it. Let's just check this thing with a meter and see. Maybe we have a circuitry problem and that's why the light's not turning on. So let's just see if this bulb is burned out or not. Nope, this bulb is good. So we have a circuitry problem. We have to figure out why this isn't turning on the MPX light. I actually have something to do on this. Either that or it just wasn't making a connection. Let's just put the light back in, screw it all the way in and see if it lights up. Nope, okay. Now I gotta figure out why the stereo light's not working because the unit is clearly in stereo. Give me something to test. Okay, I'm not getting any stereo on this receiver. I'm just clipped on and I'm monitoring the output from the detector here. This is one of the buffer transistors right off the FM discriminator, and if we look over at Mr. Digital Scope over here, we will see that I indeed am seeing the 19 kilohertz pilot. If I hit the, I think it's the choir? Nope, sorry, wrong button. Measure. 19 kilohertz. If I go to mono mode, you'll see that that goes away because there's nothing there. So this is our carrier, so we know that the FM pilot tone is being received. Turn it back to stereo. There's our 19 kilohertz signal back. Now we just got to figure out why it's not turning on the stereo decoder circuit and decoding it. So the fact that I've got my 19 kilohertz signal with my sidebands on it in the stereo circuit and it's not demodulating, I've got to think it's one of these, probably one of these little caps in here. One of these little coupling caps has gone open because this thing's old, right? Very old. Of course, I look on the internet to see if I can find a service manual for it, but no such luck. I see a couple of them being sold for like 45 bucks on eBay, but that's not going to happen. So I guess we'll check some of these caps in this. I'm pretty sure this is our decoding circuit here. So I'm just going to flip this thing on its side and see if we can scope it a bit more. Kind of work blind here. Bring the camera down a little so I can reach it. Okay, here's my outputs here. And if I put this thing in XY mode, we won't see any, what am I looking for here? Display. If I put this in XY mode, we shouldn't see any difference. Oh, we are seeing some. Gain up a bit. Set them to the same. Set them to 20 millivolts here. So this is my stereo output that I'm doing here. If I switch it to mono, still seeing phase difference between the two. Somewhere in here we got a problem. Now I am tweaking these controls with the regular screwdriver here. It's not that I'm trying to align the unit or anything. I'm looking for changes. I'm looking to see which circuit is not performing properly. So while I adjust these coils, which looks like I'm just adjusting at random, I'm actually counting how many turns I go down and how many turns I come back up to keep the coils roughly the same position as they were before. Basically, I'm listening for any change, or I'm watching for any change to try and figure out what the hell circuit, where is my problem here, because I'm getting signals through the circuit, but it's not locking in. At this point, I really don't have much of a clue of what's going on, because I don't have a manual for this thing, so I'm kind of trying to study the circuit, look at the layout, and trying to figure out where signals go. And as you can see, this one here, I was kind of going in circles for a while to figure this thing out. In the end, as you saw, we did get the thing going after changing all the caps out on it and doing some alignment. I did get the thing going, but there was a fair bit of work on it. And one of the reasons that this portion of the video was not shown to the general public is because it'll just draw, hundreds of thumbs down. The troubleshooting, it'll just do nothing but draw thumbs down. I'm showing it to the Patreon viewers because I think you guys deserve to see a little more, to see how much work went into actually fixing this thing. And going forward, there'll be more Patreon-only videos out that show some of the procedures you have to go through to find some of these problems on this equipment that has, this is obsolete gear and there's no service data on it. So you basically, the service technicians on his own to figure out what the hell the engineer was trying to do when this was designed. And there's no documentation, so it's basically a lot of it's trial and error to see whether you can make it change, make it different, and see if you can get it going. Now, ideally, in a perfect world, I would have a stereo generator and a signal injector. I do have a signal injector, but it won't go down to the IF frequencies of a receiver like this. So it's kind of useless. It's more for servicing two-way radios and stuff. It's a VHF generator, not a FM generator. 19 kilohertz on. Put a mono on. Something right in this area here, I think. Turn a 19 kilohertz back, more in stereo. Something right in this circuit here is not switching. Okay, on this transistor I have a signal present when I turn on the stereo and it disappears when I turn it off, but I don't see anything going through this transistor. I see nothing on the collector or the emitter. It stays the same. Same with this one. Weird. Just gotta check. There's a couple of there's a couple transistors down here I'm gonna test first of all. See if one of these transistors is bad. Emitter collector base. Looks okay there. Looks okay. Yeah, it could be a little bit of leakage on that one. We'll try this one here. Okay, this transistor down here, which looks to be the one that switches the light actually on and off. Base emitter, looks like this is it here, emitter collector. Where's the base over here? Okay, that measures okay, except for that. If that's the same transistor, it looks like I got a short across it. Just gotta disconnect that one and see whether that is actually I'm measuring a short across the transistor. Okay, so it looks like when I go through here, it looks like it's labeled on the board, right? It looks like I'm going collector to emitter, and I'm seeing 0.184 drop. Point one. 0.1. Could be a germanium transistor too, though. They have a much lower voltage drop across the junction than silicon. This thing's certainly old enough that it would have germanium transistors in it. That transistor that I'm measuring would be this one up here. I think it's this one. It's one of these two that I think I'm measuring. Let's see if I can do it from the top side and see it. What I'm doing. .5, okay. 0.4, almost looks like it's shorted, doesn't it? And then here. See? Almost looks like that transistor shorted. Right down here. Of course, we can always use a test tone for testing stereo. And what I've done is I've recorded a tone, left channel 600 hertz, right channel 400 hertz. Saved it as an MP3 file and stuck it into my little FM transmitter. Going through my bench receiver here, if I go to the left channel, I get the 400 hertz. I guess it was 400 on left and 600 right. If I go to the right channel, right? And of course, if I put it to mono, you'll hear just both of them mixed together. I go to the receiver at fault, where we're hearing the same thing out of both channels. So this makes it a little easier to troubleshoot when we've got a stereo fault by having two separate tones, two separate discrete tones. It makes troubleshooting the stereo circuitry a little bit easier than doing it with music. So I'm going to just proceed to troubleshoot here with tone. Okay, continuing on with the AGS, the AGS TRIO. It is a TRIO AGS. AGS TRIO. I've got a new control here. This is going to replace this broken base control. So what we're going to do is I'm going to take out the control first of all, and we're going to transfer the wires over one at a time. We'll get the base control dealt with and then get back into working on the problem with the FM stereo circuit on this unit, because as we found out, there's a problem with the stereo circuit as well. So basically I just have to transfer these capacitors and resistors from the old control to the new one, and we're just going to do them one at a time, one terminal at a time. Easiest way to do this is probably to cut the old components off one leg at a time, and then we can transfer the wires over, or we can unsolder them, either way. But it's probably just as easy to cut the whole entire leg. Like that. That's the center one. So that's one channel, and then we'll do the same for the other channel. You see what I'm getting at, right? We'll just solder them down complete onto the new control. I know someone's probably going to say this is not the right way to do it, and I should unsolder the components completely. I don't want to put any undue stress on the leads from these ceramic capacitors, so I'm trying to switch this over in the least stressful way, which is just to cut, and we'll bend over the tabs, crimp them down, and solder them in place. That's probably the least amount of stress to the other components that are tacked on here. So I'm just going to bend my leads over at 90 degrees. And we'll put some tin on them. This is a very old control. I don't know how old this replacement is, but it looks like it's been sitting around forever. So we're going to tin the leads. And then it's just a matter of getting the control in place and reattaching the leads here. I'm just going to re-tin these other ones as well, as that may come out of there easy too. hot. Okay, that's 5 out of 6 connected. One last one here to do. We can mount the control back in place and then get back into troubleshooting the FM circuit. Mount the control back in there. See how it fits in there perfect. It's exact size. Oh, maybe not. Maybe not. It's a little bit shorter, so I might not be able to put this washer on. The shaft length here is slightly shorter than the other one. But I don't know if I'll be able to get the nut or the washer on there. The nut will go on for sure, but I might be able to get that washer in there. Let's see. Let's see whether it will go on. Oh man, I probably won't be able to put this washer on just because the shaft is just slightly, the threaded portion of the shaft is just slightly shorter than the other one, but you know what, it will screw on, so it will work. It's just not, the threaded portion on this one is slightly longer than the replacement, and even though the replacement is fully in place and it's centered and the alignment pin and everything's there, and I can tighten up the nut, I can't put that washer on behind it. Which really shouldn't be a big deal. Let's see how the knob fits on here. As I dump all the screws, control to minimum. Looks like it works. Okay, so little less tension, so we'll just spread those out a bit. There we go. Beautiful. Looks like $1 million. There, that's better. That's a bit better. It's got the alignment a little better now, I think. Yep. Okay, that part's taken care of. We'll hook up some speakers and now we can start troubleshooting the problem with the stereo decoder. Now, if you remember, I've created a dual tone FM transmitter. I use my little MP3 transmitter, and I've created a dual tone for it with a, I think it's a 400 hertz tone on one and a 600 hertz tone on the other, if I'm not mistaken. So we have dual tone. But what we should have is So what we should have here is we should have the 400 hertz tone in the left channel and the 600 hertz tone in the right channel. And of course, if I go to mono, we hear both. Right? That's what we should have. Left channel, right channel. On this unit, we only hear the mono channel regardless whether we're in stereo or mono mode. So we have a problem with the FM stereo decoder. So now the remainder of this video, because now of course tone controls now should work. Now we need to work at the problem with the stereo decoder, which is a little more of an issue only because I don't have any schematics for this. So I'm going to be looking to see if I can find a schematic for a Trio, what is it, 305? A 305 or 3, I think a 305 or 30G maybe, it's hard to read it. Trio 30G. Let's see if I can find a schematic for the decoder board, because it'll be a lot easier to walk through that if I actually know what stages are coupled to each other. But we definitely have a problem, and as we saw from earlier in the video before I changed that control, I was making some progress, but we still have an issue here. The level's low. This should be the multiplex level over here. Aha, that's the multiplex level.
Nothing on the radio today.
For a chance to win the weekly 8 p.m. grand prize of $10,000.
What you make me do? What you make me do?
And tired.
，Join at bcaa.com. BCAA. Membership is rewarding.
Good news and bad news from Go Dodge Surrey. The bad news is they have way too many new 2017 vehicles. The good news is they're selling them to you at cost. See a copy of the invoice, buy your new ride for cost, don't pay any extra fees, and free lifetime engine warranty. You pay what they pay. For example, get a brand new Ram Hemi 4x4 for only $31,000. You save over $17,000 on that deal. Visit GoDodgeSurrey.ca or 6280 120th Street in Surrey.
My name is Jared Lee, and I'm the owner of Central Kitchen and Bar in Kelowna. At my first job, things were a lot different. Nobody talked about safety. Everyone just assumed you'd figure it out. What I know now is that safety starts with communication. Make young workers feel that they can talk to you, that it's okay to speak up and ask questions. It's good for business, and it's the right thing to do.
Talk to your young workers about safety in the workplace. Learn more at worksafebc.com/whatiknownow.
Life is full of surprises.
Wow, did not see that coming.
If you have to deal with the surprise of a car accident, bring it to Boyd Auto Body and Glass.
Your car is repaired by trained technicians, and our customer service reps will make sure you know exactly what's going on with your vehicle.
Wow, did not see that coming.
As one of the largest operators of collision repair facilities in North America, Boyd is full of pleasant surprises.
Bring it to Boyd. Insist on Boyd. Auto Body and Glass.
At Westminster Savings, we believe you deserve more. Like more personalized service for your business. That's why our small business experts make it their business to get to know your business. It's how they're able to offer banking services to meet your needs and advice to help you grow. Get the business banking experience you deserve with Westminster Savings. Switch today to get 6 months free and a $200 welcome bonus. Visit wscu.com/yourbusiness to learn more.
What's Chevrolet up to, you ask? How about up to 20% of MSRP cash credit on select 2017 models? That's up to $6,000 in cash credits on the sporty Cruise Hatch or up to $16,000 on the powerful Silverado HD. Get up to more fun in a vehicle that's up to your standards. Now, it's up to you. Visit your Chevrolet dealer before October 31st and get up to 20% of MSRP cash credit. Visit Chevrolet.com.
Vancouver is Jack 96.9. Download it today and discover a new way to listen to over 400 radio stations. Radio Player Canada. It's where Canadian radio plays, including this one-of-a-kind beauty of a station, Jack 96.9.
Ah, shit. Aha, 11 ohms. It's a 10 microfarad, 16 volts. So worst case scenario is 8 ohms, and this one's coming up at 11. So this cap is bad. Let's just try a few of these electrolytics. This is in the input where the multiplex signal goes from the FM board, which is here. This is the FM IF, and it goes into the actual decoder board. And I'm thinking maybe my levels are a little off, and that's why it's not decoding. So we'll try a few of these electrolytics in here that look to be, they might be the culprit here. There's 3 of them in a row right here. That one, and that one, and there's actually another one over here. So there's 4 of them in this area here that could certainly create problems for the FM stereo decoding, especially if they go leaky or the ESR goes really high like that one has. So we'll try these one at a time and see whether it makes any difference to the FM. When I tried rocking some of the transformers back and forth, you know, the turn here and a turn in and a turn out, it didn't seem to make any difference. Like there's no tuning seems to do anything. So we have to have a component that's going bad on here. When I get it, this is 2 separate tones. So there'll be a 440 tone in the left channel, a 600 tone on the right. So when it does kick into stereo, we're going to hear it for sure. We're certainly going to hear it. So we'll just do this other one next to it here. I'm just going to do these 2 10s first, and then we'll do the other ones. But definitely one of these ones here could certainly causes some problems, that's for sure. Where's that going to? Oops. Pulling the wrong part there. This one here next to it. Now this capacitor that I'm soldering right now is directly on the multiplexed FM line going into the circuitry. And that one actually measures in spec 4.7, but it's old, and ESR isn't the whole story. We'll see what the capacitance measures on this thing here and see if it's lost capacity. That looks okay. 16 microfarads. Capacity wise, ESR wise, this one's okay, but for the sake of it, let's change it. Because as you can see, this one here is the direct input. So this one will have a direct impact on the quality of the signal getting into the decoder board. feeds right into this transistor here, the first stage. So this one basically couples the multiplex signal into this first stage. I have a schematic that is not the exact one for this unit, but it is a later model, so the circuits are probably going to be similar. And that shows, there's a transistor here, that shows that there is a 10 microfarad capacitor, which that's what this is, going into Q1, which will carry the signal in. And there's a couple of other capacitors in here as well that I'm suspecting. This is the other one here, C14. This is the other one I changed, the other 10 microfarad. And if we look at the signal path, it goes into the transistor and it comes back out of the transistor and it ends into this other, through this other capacitor going into this tuned circuit. And this is our circuitry here for the decoding and turning on the stereo light and stuff. So this circuit board here is not the exact one, but I think it's probably fairly close, because this schematic that I've got here, this one's from a TK40, and this receiver here is a TK30G. So this is a later model, but I think the circuitry is relatively similar between the two of them. I see a lot of parts that are of the same type of value, so if we look at the signal coming into here, so this is the multiplex signal on the scope here. If we look at the scope, this is the multiplex signal coming in. If I just turn this down a bit, you'll see it's got the 38 kilohertz signal is actually modulated in there as well. That's what the wider portion of this carrier is. And this is going through the buffer. Here's going through that other second capacitor. It goes into this coil here. From here it comes down. And you see it's going into another transistor here. So that's those two capacitors replaced. There's also this other one here. So I'm going to change this one out as well. This one here, I don't trust it. I don't trust any of these old caps as far as I can throw them. They're old Elnas, and now much of this footage you guys are seeing right now is only Patreon only. This one here, let's check out the ESR on this one. See how bad this one is. This one's a 30 microfarad. $33 ohms. It should be more like about 3 ohms. So we know this one here is bad for sure. For sure. There's that bloody dog. That's measuring like 100 microfarads. A little bit high. But the ESR is bad on this one. So this one here is, we know this one's bad for sure. And go find a 30 microfarad Actually, it'll probably be a 33 because I haven't seen a 30 microfarad. I've never seen a 30 microfarad replacement. I'm not saying they don't make them, I've never seen one. So I have a new one here. It's a 33 microfarad. Get this one in here. In case you guys are wondering what I'm doing, I heat up the foil to let the component go through, and then I wiggle it. I twist it a bit as the solder is cooling. That way it doesn't stick. That way I can go and do the other side. It's a little trick I learned years ago. When if you don't want to use solder wick or a solder sucker to take off the solder on these plated boards because they've gone over all the traces with solder, sometimes it's just as easy when you heat it up and you stick the component through. Just roll it in your fingers to keep the wire turning as you remove heat, and it won't make a connection. Then when you heat the other land on the other side, you can push the part through, and because the first side didn't connect, didn't fuse to the board, you can push the component all the way down. Just a little tip when you're working on these boards like this that have got tons of solder on them, and they'd be a pain to remove it all to try and replace parts. This just makes things just a little bit easier when you're working with these things. Okay, so that's those three replaced. Okay, we got one more electrolytic on this thing to change. Is this one right down here? This is the last of the electrolytics on this board. That's this one. It goes right from here to this ground. This is a 50 microfarad. Let's just see how this one fares. I'm sure it's probably bad. Yes, this one's completely open. This might be the one that's causing the problem. You can see that's ESR on this one is just completely open. 50 microfarad, 15 volts. This is probably a filter Let's just see what the capacitance meter says. This one should actually test open. The ESR is completely dry on this thing, so this thing probably doesn't even measure any capacity. And of course it does, but the ESR is shot on this one. So let's find a new 50. I have to probably settle for a 47. That'll be close enough. So once again, what I'll do is I'll put the component in on the positive lead in here. Like there. And I'm going to just heat up the board a bit. So I get the first lead through. And now the first lead's through, and I've twisted it a bit so now it hasn't stuck to the board. Now I heat up the other side, and I can push the component all the way down. Okay, let's see what happens. Oh, my antenna wires come off. Still nothing. I'm just going to just try rocking these transformers back and forth a bit and see whether we're just off tune a bit. I'm turning them no more than like a half a turn each direction using a insulated tuning tool. Just listening for any changes. Okay, another cap that I found that's also bad on it is this one, but it's right on the output of the IF board. C22 is also one that it's a 10 microfarad, and its ESR is through the roof. So we're gonna get another one of those and try that one. just got a dead carrier running now on this low end frequency here. The fact that I've been finding so many of these ELNA caps bad in the IF circuit, I'm just going to work my way back and change the other remaining ones and see maybe perhaps that's what's causing this thing not to pull in stereo reception, because they're all measuring bad. Just got to find it here so that I can remove it. Sometimes finding these things isn't the easiest thing in the world. Should be right in here. See if that's one lead in there, or is this the other? Jeez, what's going on here? I can't get this thing hot enough. Alright, one side of it unsoldered, the other side just, I can't get the bloody thing. It's right on a ground lug, and all the heat is going into the chassis, and I can't get this thing hot enough to unsolder it. What the hell? One side of it's undone. The other side goes into this great big lug right here. I got the iron cranked up to like 900 degrees and I still can't get enough heat in here to melt the solder and get that part out. I guarantee you this one's bad. I can just tell by looking at the rubber end on this thing. This one's bad. 11 ohms. That's getting there. Shouldn't be any worse than 8. It's about 15, so it definitely is. Check it out, that's for sure. I'm going to do the last 2 capacitors in the decoder board, which are right down here. Then all of the electrolytics will have been replaced on both the IF board and the MTS board. This is a preamp board here, and as is that one. One's a driver board for the power amp. This is the preamp board here. This is the driver board. Oscillator is down here. Your AM IF is in here. FM IF is in here, and this is the MTS board. So there's 2 capacitors that I haven't done yet. I'm going to change these 2 out here, and that way any problem that's caused by a capacitor will have been eliminated. I have a sneaking suspicion that somebody else got into this unit before it was brought to me, because the paint seals on the controls here that were painted and sealed, they were all broken. So somebody's been into this thing. We may be looking at an alignment problem. Let's say I've rocked a lot of the transformers back and forth about half a turn either way from where they started, so I haven't changed any of the alignment, so to speak. I just tried to tweak to see whether it could kick into stereo or not. But we may have an alignment problem on this that I have to deal with. But let's change out the last 2 capacitors, even though they've measured okay. ESR wise, they've measured okay. They're also still very old, so I think it's time just to swap them out, just for the sake of swapping them out, because they are old. So there's one, a 20 microfarad. And I bet the ESR on this one's okay, but we'll just take a look for the heck of it. It's probably okay. I guess it's a little high. It's a 20 microfarad, this one. I'll have to put a 22 in. Okay, this is the last of the electrolytics. So now they've all been done on both the IF board and the stereo decoder board. So if our stereo problem is being caused by a failed capacitor, then it should work. Okay, I think I'm recording now. As you can see, I'm very close. I got my stereo light triggering here, so I'm very close now. I've changed all the capacitors. I think it's just a matter of tuning this thing a bit to get this thing to stay in stereo mode. Well, this is really maddening, okay? I changed all the capacitors on this thing, and I'm pulling my hair out. Why is this bloody thing not receiving stereo? And I was listening to my test tone, right? And it sounded like the signals were mixed. I was just flipping through the stations. I thought, damn, the light comes on like on peaks, but on quiet stuff it's not lighting up. This sounds like stereo. So I went and I got some music that is in super stereo. This would be the Beatles. And this bloody thing is actually receiving stereo. Listen to this. I can't play this, but I'll let you guys hear it so you can actually hear, because what the Beatles did was, and a lot of the stuff, especially on albums like Rubber Soul, for example, they recorded the music on the left channel and they put the vocals on the right channel. It's perfect for testing stuff like this. Take a listen. Okay. Tell me why. Okay, and now the left channel. There's the bass, right? No singing. So we gotta shut this off for a bit here because I don't really want to have any trouble. So we'll wait for the next song because I put a few songs on here. This bloody thing is working. It's just the stupid light isn't coming on. So somewhere in the stereo detection circuit in this area of the board here that turns that stupid light on, something is not triggering it. But that bloody thing's receiving stereo, and I've been pulling my hair out on this thing for hours trying to figure out why the hell is this light not coming on. And I'm assuming it's not receiving stereo, but it actually is. Let's pick another song here. Okay, listen to this.
Well, I'd rather see you dead, little girl, than to be with another man. You better keep your head, little girl.
Definitely receiving stereo. Here's the left channel.
Man, that's the end.
I can put it in mono. I know I'm getting stereo. Ah! There it is. That's it. That's it. It's stereo. It's working. Excellent. I don't want to play this but yeah, we got our stereo light back. So that's all it was just this coil was I mean, it shows where it was marked. I just had to turn it over about a third of a turn. Not even that. There's a dot here, right, where these were aligned from the factory, and I just had to tweak this one ever so slightly, and that seems to have solved my problem. Again, we can hear it very clearly here on the Beatles. My test tone doesn't show this effect as much because I've got 100% tone on the left channel, one tone on the left, and 100% on the right. This old circuitry isn't quite as good as the new stuff. I got them grinding pavement in front of my house here, but listen to this. I'll put some Beatles on here for a few seconds. You'll distinctly hear the difference in separation. Here's the left channel, or the right channel.
Had you come some other day, then it might not have.
And then the left channel. You hear the bass on one channel, and the other channel.
Call your number on my wall.
And we put them both on.
We'll get a call.
There's mono, stereo. Definitely it's working in stereo, and I've got my stereo light back here, right here, which makes me happy. So if I tune around the dial, as you'll see as I tune the dial,
Post.ca/ship-free for details.
About 7 minutes.
The price to set it up. Oh, see that.
I'm not getting on all stages. Let's check this out. Okay, here we go. That's my
Let's explore the complex relationship.
That's a mono station.
Narrator.
Stereo.
You can be off to the grand. Sydney
Mono.
tells me to take the final shooting.
There we go. I love it. Love this old technology. Get it back working again. So what we've done on this one is we've just to recap this one. What I've done on this is I have recapped, just a recap. We're going to recap what we've done on this one. I recapped the IF board. So I changed these capacitors here, 3 of them here on the FM IF board. And I also changed all of the electrolytics here on the MTS board. And I did have to tweak the coil here. I had to tweak a couple of the controls here just to align it. But it wasn't off by much. I had to move this here about a quarter of a turn. And that's basically the only one I had to adjust. Everything else, nothing else was touched on, and everything else is stock. And this unit is
It's the details that matter.
now ready to go back to the owner. So let's put it together and see how it looks once it's back together. And there the unit is back together. Sorry about all the racket out there. As I say, they're anyway, thanks for watching. Hope you enjoyed this restoration of this old AGS TRIO. Of course, TRIO, as we all know, later became the Kenwood company. Kenwood bought out the TRIO brand from AGS. This was American General Supply. It was made for them. It was made in Japan. Hope you enjoyed this. This version that you guys are watching on the regular channel is the shortened, condensed version of this. The Patreon viewers, you guys get a treat when I release the full version showing the full restoration, because this thing's been here for a few weeks and I've been working on and off this thing for several shots at it to actually find the problem with it. And I know that it looks simple, just changing the caps, but there was actually a little more involved that. So Patreon viewers get to see the whole thing. Thanks for watching.